So integration by parts can actually be applied more than once. And so let's do an example to show you exactly what I mean by that. So we're going to evaluate the integral of x squared times e to the 3x dx. So remember, the first thing we always have to do is choose u, which, remember, we use Liate to help us choose what u is. So here, the first one I meet is algebraic function because of my x squared. So then I'm going to make dv be everything else. And so then du, right, the derivative of u is 2x, and then v, the integral of e to the 3x dx, right, remember, this is going to need a u substitution where u is 3x and du is 3 dx, so 1/3 du is dx, right? So this becomes the integral of e to the u times 1/3 du, right? We can pull out the 1/3 since it's being multiplied. Then we know the integral of e to the u or e to the x, right? It's just itself. So this is just e to the u, so that becomes 1/3 e to the 3x. So v is 1/3 e to the 3x. So now we have everything we need in order to plug into our integration by parts formula, right? So our original integral is equals to u, we said, is x squared, v, we said, is 1/3 e to the 3x, and then minus the integral of v is 1/3 e to the 3x, and du is 2x dx. Okay. All right, so now we can start simplifying things. So this becomes 1/3 x squared e to the 3x. And then, right, we don't have a simple integration antiderivative formula to integrate this. So, right, what we can do is try to simplify it. So we have the 2 multiplied and the 3 multiplied, so we can multiply those together and pull out the 2/3. Right, but we're still left with x times e to the 3x. So that is still, right, a product of 2 functions. And so we're going to need to do integration by parts on this in order to solve it. So again, use Liate to choose u. So I'm going to do this one in purple so that we know the difference between the 2 integration by parts we have going on. So we're going to let u be x because that's algebraic. And then dv is going to be the e to the 3x dx. So du is just the derivative of u, which is just going to be 1 dx, which is just dx. And then v is going to be the integral of e to the 3x dx, which we did earlier, right? We already did this integral. So I'm not going to repeat this whole u substitution when I know I have the answer right there. V was 1/3 e to the 3x. And now I'm going to plug in everything, into my integration by parts formula. So, right, this is the integral we're doing right here. So our u is x, our v is 1/3 e to the 3x, and then our v again is 1/3 e to the 3x, and then our du is just dx. So this becomes 1/3 x e to the 3x minus, remember, I can pull this 1/3 out, and then I know the integral of e to the 3x, right? That's the one that we did up here with this u substitution. So this came in handy, this u substitution, right? So this becomes 1/3 x e to the 3x minus 1/3, and then this was 1/3 e to the 3x. And then we have our plus c here. Right, so this is just 1/3 x e to the 3x minus 1/9 e to the 3x plus c. So that's what this integral here was equal to. So now we get to plug that in, right? So let's make sure we also pull down this, and we don't forget also the 2/3, right? So we have 1/3 x squared e to the 3x minus 2/3, and then that integral we said was 1/3 x e to the 3x minus 1/9 e to the 3x plus c. And now we distribute this 2/3 to all of these terms, right? The 2/3 times c, that's just whatever, some other constant. So we just keep that as c. So 2/3 times 1/3, that's going to be negative 2/9 x e to the 3x minus, and then 2/3 times 1/9, that's going to be positive 2/27 e to the 3x plus c. And this is our final answer.